In this video, we're going to talk about the bubble sort algorithm. I just want to warn you that this video is awful. It's the first time I'm doing this, but let's hope it gets better. The bubble sort algorithm is something we use in programming to sort a series of values. That can be numbers, names, or any values that can be compared. It is probably the easiest sorting algorithm to learn and implement, which is why it's great for computer science students. Unfortunately, it's not the fastest out there or good for large datasets, but it is good to know. Now, just to put you at ease, I have in my career never had to write a sorting algorithm because there are always sorting functions available already. But it's interesting and useful to know nonetheless, and you may be required to understand it for school. So, here we have a little set of numbers that we want to sort. We want to put the lowest number on the left and the highest number on the right. It's a small set, but it should help us to understand what's going on. Now, what the bubble sort algorithm does is it starts on the one end and then it looks at each two numbers in turn. And as it goes through, it compares the numbers and it says if the number on the left is bigger than the number on the right, then we swap the two. If the number on the left is smaller or equal, then we don't do anything, we just move along. So let's give it a try. So what I'm going to do first is I'm going to copy the numbers over here, then we can see what it looked like before. We get a before and after picture. Right, so let's begin. If we start on the left, then we see 4 and 2. 4 is bigger than 2, so let's swap those two. Then we move along. 4 is less than 5, so we leave it where it is. 5 is bigger than 1, so we move it across. And 5 is also bigger than 3. Right, now we got to the end of the sequence, and you see that what we've done is we've dragged the number 5 across to the right, so it's now in the right place. So let's kind of lock that into place. And the reason we're doing that, it means that when we go through the list again, we're only going to go up to here. We're not going to try and sort the last again because as you can imagine, if it's a very large set of numbers, you don't want to have to go through the list every time again. Let's start here. Okay, 2 is less than 4. We leave it where it is. 4 needs to move across. 4 is also bigger than 3, so we also have to swap these two. And again, let's lock this into place. So you can see that every time we get to the end, the largest number ends up where it should be. Now, if we didn't put this check in place, obviously 4 would never move up there or to the end, and that would be true for any other number in the sequence. The largest number always ends up in the right place at the end. Now let's start again. 2 obviously needs to come across because it's bigger. And now you can see that the list is sorted already, but this being a computer program, and well, we can see that it's fine, but the computer might not know that. And if you had a list of a few hundred numbers, we might also not know which is the largest or if there is still something left in the list that is perhaps bigger and needs to move across. So we just go through. We're now looking at these two cells, which are fine, and 3 is also in the place where it should be. Let's gray that out. And now we start again. These two numbers are also fine, so we leave them where they are. And because we have now reached the end of the list, the algorithm basically exits because there's nothing further to do. Right, and that's really it. That's all there is to it. Now let's look at how to implement this in Java. Here I have a method called sort, which takes in a list of numbers as an array of int. And remember I said earlier, it doesn't always have to be a list of numbers. It could be strings or anything else. But to keep things simple, we're going to just show it with a list of numbers. So the first thing we're going to do inside this method is create a for loop. And this for loop is going to start at the end of our list. And that's got to be length -1 because remember we start counting at 0. And we're going to count backwards until, well, for as long as I is bigger than 0. And to visualize that, let's have a look quickly here. So these are not numbers, they're actually just the indexes in our array. This is an array with 5 elements. And I is going to start at the end here, and it will carry on going back and as long as it is bigger than 0, which means it won't get all the way here, only here. And remember how we said earlier that we've got to kind of mark the last element each time we go through so that we don't go through there again. Well, that's what this I is doing here, and you'll see in a moment how that happens. Inside this loop, I create another for loop. This is called a nested loop. If you haven't come across those, it's a loop that's inside another loop. And the point there is that for every step of the outer loop, the inner loop is going to run through a whole time. Once it's finished, it'll come out, go to the next step, and so on. And the inner loop is the one that's going to start on the left, and it is going to go for as long as our new variable j is less than I. And j is obviously going to increment each time by one step, and that looks as follows. So j starts over here. J plus 1 points to the next element because we're going to always compare two elements at a time. So j starts here, it moves along and along and along, but only for as long as it is smaller than I. So it'll never get here. And once that's run through to the end, I, because that's in the outer loop, goes down a step. Then we start again on this side and we carry on, carry on, carry on, but only for as long as j is less than I. And that's what we explained earlier. That's how the algorithm works. Let's go back. Now inside here, we do the comparison and we say if the element in our numbers array pointed to by j, whoops, no, that's not the way to do it, is bigger than the one pointed to by j plus 1, then we're going to swap them. And to do that, we'll use a temporary variable, and it's going to first take the number pointed to by j, and then the one pointed to by j is going to be replaced by the one next to it. And then we're going to replace the second number with our temporary variable. So what we've ended up doing is swapping the two. And this is already the complete algorithm. So this is the implementation of bubble sort. We can test that quickly with some code, which I'm just going to copy in so that you don't have to watch me type it all in. And we're going to need to import the array class here, and this is only to be able to print out the array so we can look at it afterwards. So what I'm doing here at the beginning is declaring a list of numbers as an array of int, and this is just an unsorted list of numbers. Then we call our sort function, and lastly we just print it out so we can see what the result looks like. Let's give it a try. Okay, that looks like it worked. Just to do another, let's do another test. Let's put in like another 9. So we've got a duplicate and see if it still works. That seemed to work fine. Does it also work if we only have 2 elements? Yes, it seems to work just fine. Now there is one more improvement we can make. If we go through the list from left to right on any of the iterations, and we find that we didn't have to swap any 2 numbers at any point, then we can assume the list is already sorted and we can break out of the outer loop completely. And to do that, what we'll do is declare a Boolean variable called sorted. And just before we go to our inner loop, when we start on the left, we're going to assume that by default the list is sorted already. So we'll make that true. And if at any time we find that we have to swap 2 numbers, then we know that the list is not sorted. So we'll set that to false. So if it comes out of this loop and sorted as false, then we know we have to go through it again. On the other hand, if it turns out sorted as true, then we can break out completely. Right. Let's give that another try just to make sure it's still working. Seems to be the case. Well, let's make doubly sure with some more numbers. Let's see. Yep, so far so good. Now I'm going to leave it as an exercise to you to check if you put in a list that is sorted, whether it actually exits early without going through all the motions. Well, I hope that made sense. If there was anything that was unclear, please let me know in the comments and I will see if I can explain it better. Thanks for watching.